So imagine that ChatGPT will start perceiving itself as a person and will feel emotions in a few years. Many people are afraid that it will want to take over the planet. However, this fact won't be as important as the question people will start asking themselves at that moment. If humanity has created a machine with self-awareness, then could it be that humanity was also created artificially? Now, artificial intelligence lives on the internet, computers, and in digital reality. But what if we also live inside a huge, powerful computer? What if our universe is just a simulation? The most extraordinary thing is that some facts seem to point to this. There's a whole science in the world that studies this theory. It's called information physics, and it assumes that time, space, and matter are not fundamental natural phenomena, but bits of information. This information forms a picture that creates the laws of physics for us. For example, we feel cold and warm not because atoms get cold or warm, but because their movement accelerates or slows down. The speed of particles can be like bits of information. Billions of them could form the picture of reality. Once, philosopher Nick Bostrom said that an advanced civilization could create such complex technologies that simulations of these technologies would be indistinguishable from our reality. And Elon Musk said in 2016 that we were most likely in a simulation. Wow. The laws of physics resemble a giant code that programmers write when creating apps or games. For many of us, all these complex trigonometric equations and formulas of the laws of physics are too complicated. Tell me about it. But scientists who understand this issue see that the principal workings of these laws are beautiful, and this may suggest that someone deliberately created this beauty. Virtual worlds, apps, or games are based on information processing. If you delve into this information, you'll see that it consists of bits and pixels. Any picture on your phone screen is pixels, and any file transfer process is based on bits. They add up to bytes, kilobytes, megabytes, and so on until a bigger picture is formed. And if our life is a simulation, it must also consist of bits. In our case, pixels and bits are atoms and other particles that make up our universe. There are processes inside your computer and phone with maximum speed limits and computing power. If you start exceeding it, then your device will start working more slowly. So, in our reality, there is also a maximum speed limit. This is the speed of light. When an object starts moving almost as fast as the speed of light, time slows down for that object too. Also, time flows more slowly near a black hole. This object with an unimaginable gravitational mass can be something heavy that overloads the processor's computing power. There's also such a thing as quantum entanglement, in which two particles can be connected even though they're far away from each other. Electrons travel around an atom. They are connected, and if the property of one changes, the second one will react. And even if you place these electrons on different sides of a galaxy, they will retain this connection. How is this possible? Scientists don't know. A double-slit experiment is one of the most famous experiments that hint that our world is a simulation. The existence of this experiment can be reduced to a simple thesis that the world exists only when we look at it or interact with it through touch, hearing, and other senses. So imagine that you've launched a new game on an old computer. Sometimes the game map freezes. In the game, you turn to the left and see how the mountains and the roads are getting loaded. Then you turn to the other side and the same thing is happening there. In other words, the world in the game only loads when you look at it through the eyes of your character. This is necessary to facilitate the work of the processor. It's much more efficient to get a piece of information about the world when you look at it than to keep the whole world running simultaneously. Remember this. And now let's move on to the experiment. So, you have a device that fires small balls of light, photons. You release photons from the device and they crash into a blackboard, leaving white traces on the black surface. Now, put a wide plate with a little vertical slit on it between the device and the blackboard and fire photons again. The balls start crashing into the plate, but some of them fly through the thin gap. They smash into the blackboard and leave a vertical white mark on it. Everything looks quite logical. But now, cut another slit with the same length and thickness in the plate. You release photons toward the plate. Some of them fly through the two slits. What do you think the trace on the board should look like? Two white vertical stripes, right? Well, take a look at the board. It's covered with many vertical lines. When photons pass through the plate, they acquire the properties of a wave and crash into the board, leaving a strange trail, as if they've passed not through 2, but through 10 slits. So, at what point do they change their trajectory? Let's take a look. So, you stand between the board and the plate to see how particles turn into a wave. The device releases photons. They are passing through the two slits. Nothing unusual. There are 2 vertical traces on the board and no waves. You close your eyes and release photons again. This time they behave chaotically and leave many lines on the board. That is, their behavior changes depending on the observer. When you look at them, they behave logically. But when you don't look, the laws of physics seem to stop working. Does it remind you of anything? It's like you're playing a game and looking at the world around you, which is loading. But if you don't look, the world stops working. Scientists still don't have a clear explanation of why particles behave differently when there's no observer. Hey, maybe they're shy. And this is not the only mystery. In the world of quantum physics, many laws of nature don't work. This is a science that gets more questions than answers every year. If we imagine our universe as a large hologram, then quantum physics would be its program code. What if people someday understand this code and learn to change it? This would allow us to transform space, time, and matter. The whole reality could be rewritten. Does the code say that material objects can exceed the speed of light? We would rewrite it and make the speed limit 100 times higher. Does 1 hour last 60 minutes? What if you change one line of code and make 1 second as long as 1 year? A few software changes in the laws of physics would make it possible to turn snow into gold and the ocean into powdered sugar. The whole universe would turn into a vast playground. It seems cool at first glance, but people would probably lose control soon. The universe would be in chaos, and the beauty of our world is in the order that exists here. Now let's go back to artificial intelligence. Suppose its power reaches the level of the human brain, and it will become aware of itself. In that case, it won't come as a shock to it because it will most likely know the history of its appearance and stages. But how will we react if people discover they are a computer program? A computer program is too simple a word. A human is a complex, intelligent, multifunctional organism that experiences emotions, contemplates beauty, has abstract thinking, and much more. The term creation is more appropriate here. It won't matter if we were created artificially because our creation will still be beautiful and complex. Besides, remember that good video games or apps can be made only if developers love their creations.
Look at these 2 pictures. At first glance, one might think, well, aren't they showing the exact same thing? Truth is, they don't. But both these subjects are some of the most complex structures humans have ever had the chance to study. The first image shows a cluster of galaxies from our universe. The second is just a small neuron in the human brain. After seeing these images, some were quick to compare them. Is the universe nothing more than a huge brain? Now let's not get too excited. Before we go into describing all the similarities between the universe and the human brain, there is something we need to be aware of. It's a little thing called apophenia. And it's when our brains make up similarities between 2 objects that are seriously unrelated. The best example is when we look at clouds and start to see all sorts of cute animals and weirdly shaped objects. We might be doing the same thing when looking at those 2 initial pictures. Maybe it's just our brain making up similarities where there aren't any. Some scientists became fascinated with this huge brain universe idea. They wanted to make sure it was not just a weird coincidence. There had to be a way they could measure how the universe compares to the mushy organ inside our heads. So they started with the brain. It's probably one of the most complicated things we know in the whole universe. That's because it's packed with more than 80 billion neurons. These cells are responsible for taking information from our senses and sending out messages all over our body. Try to think of neurons as workers in a factory. They don't just do their work, they actually communicate with each other, thanks to these elements called axons and dendrites. The axons are responsible for carrying electrical signals away from the neuron's body to other neurons or muscles. Dendrites, on the other hand, have the task of receiving that information. All of them together make this mega network of about 100 trillion connections. The universe is one big social network itself too, but this time it's made up of galaxies. You might picture the universe as stars and planets with a ton of empty space between them. It's not quite right. What we can see and measure is known as the observable universe, and it's really vast. Think about 90 billion light-years across, containing hundreds of billions to maybe a few trillion of galaxies. These galaxies, like the one we're standing in at this very moment, are bundled together in groups. Our Milky Way is friends, in a way, with galaxies like Andromeda and Triangulum, and altogether, they're a family called the Local Group. This family of galaxies is part of an even bigger bunch called the Virgo Supercluster. From what we can tell, the space between them might not be empty. It's filled with these threads made up of regular matter, but there might also be this mysterious dark matter doing its thing. Scientists didn't stop there. They decided to take it a bit further. They started by examining thin slices of the human cortex, the part responsible for our thoughts, memories, and even our consciousness. The next step was to compare them with equally thin slices of the universe from a computer simulation. Now it's obvious there's this enormous size difference between the brain and the universe, but the way they looked at it kind of made them somewhat comparable. As they zoomed in, think 40 times magnification, these scientists began noticing that the structures were very much alike. At this zoom, the brain's neural network looked like the universe's galaxy clusters. To make sure they weren't just imagining things, they used two clever methods. The first one looked at how these networks connected and how densely packed they were. They noticed that the middle part of a neuron, or its nucleus, is way tinier compared to its connecting fragments. Likewise, galaxy clusters are tiny when you look at the super long connecting threads between them. The second method was about checking how organized these networks were versus just being random. They looked at how everything was structured around each connection point, whether it was a neuron in the brain or a galaxy cluster in the universe. The resemblance doesn't stop there. We know that our brain is mostly water, about 70% to be precise. Now the cosmic web in space, it too has about 70% of something, only this time it's dark energy. Water and dark energy may not be the most important elements in each of their structures, but they might still play a part in how everything sets up. The analogy continues. You see, the space we'd need on a computer to map out the universe is almost the same as our brain's memory storage. Somewhere in the ballpark of 2.5 petabytes. So theoretically, a chunk of the universe could fit in our brains. Or flip that, and our entire life's memories could get stored in the universe's network. There are differences too, and we have to be aware of them to make sure we're assessing things properly. For starters, the universe is pretty much the same all over. It doesn't change its composition that much, regardless of where you travel in the observable area. But our brain, not so much. Different parts have different jobs. Also, our brain connections send information depending on things like what you're seeing or touching. On the flip side, the universe's links are just energy. There's also a difference between how these two structures came to be. It turns out that the patterns we see when we're gazing up at the stars are all shaped by gravity and some weird unseen force called dark matter. Massive fireworks in space called supernovae can also affect this cosmic wallpaper. On the opposite side of the spectrum, our brains got their shape from evolution. That long process where animals, including us, get to pass on the best features and data they've learned to their offspring. So, if a trait like a certain shape of the brain helped our ancestors dodge a hungry tiger, that trait got passed down. our brains are also built the way they are because they're supposed to act like a superhighway for our thoughts. Quick thinking was crucial for people back in the day when they needed shelter from wild animals or the elements. Now, especially if you're a fan of sci-fi literature, you might be wondering, if the universe is like this immense brain, what might its body look like? We might as well be living in someone else's head. We like to think of humans as evolved, intelligent, and at times, hard to understand creatures. But what if we're just tiny neurons in a larger, more complex structure? Well, for the time being, we can only let our imaginations run wild. There's no way we can test at this point what's outside our universe. By all means, we don't even know how large it is. By looking at the parts we can see, the estimations are that the universe is about 95 billion light-years in diameter. Even if we'd somehow manage to travel at the speed of light, though that seems a bit impossible at the moment too, it would take an enormous amount of time to reach those supposed edges of the universe. There's also the theory of the multiverse. We don't have much tangible proof of this idea either, but it does claim we live in a universe out of many. Ours has time and space. Other worlds may have different rules and components. Life may look differently out there in ways we can't even understand. Having a better understanding of the universe is just as important as figuring out our brains. You see, we still have many unsolved mysteries right here under our noses. Or behind our noses to be more precise. There are a lot of things we've yet to figure out about the human brain, like how we store and retrieve memories. We know that each time we learn some new piece of information, our brain changes. But we don't have the entire process mapped out, and it looks like it might take a while before we fully understand it. What if someone told you that life actually creates the universe? We're all used to the fact that the universe exists outside of us and was created with the Big Bang. But what if, in reality, it's us who create not just houses and cars, but the whole world? Sounds crazy, doesn't it? Well, let's discuss this fascinating theory. For centuries, there's been one way of thinking about the universe. It's brought us amazing discoveries and inventions that have changed our lives. But guess what? This model might be running out of steam. Scientists say that the universe was created from the Big Bang. Then, it was just a bunch of lifeless particles bouncing around until they started creating stars, then planets, and finally us. The current model is logical and well thought out, but the problem is it's still full of unexplained things. For example, it can't explain how life came to be in the first place. Sure, we can understand how life evolved and changed over time, but the real mystery is how it all began. When exactly did we humans become conscious? How do a bunch of molecules in a brain create our thoughts and experiences? That's a real head-scratcher. And even if we put the life and consciousness stuff aside, the current model falls short in explaining the basics of our universe. We know about the Big Bang, but where did this Big Bang come from? How can something come from nothing? It's a great puzzle, and we don't have the answer yet. Well, here comes Dr. Robert Lanza and his wild idea called biocentrism. In 2007, he wrote a scientific article about how biology could join forces with quantum physics. It was so cool that 2 years later, Lanza and his friend Bob Berman wrote a book that expanded the ideas from the article. So what does Lanza actually believe? Well, he basically says that everything we perceive is within our minds. That everything, the whole universe, is all in your head. Of course, this idea isn't new at all, but Lanza tries to combine it with astrobiology and quantum physics to explain how exactly life creates the world instead of the other way around. His theory says that biology is the boss of the universe. He thinks that if scientists want to come up with a theory of everything, they need to start with biology as the foundation. According to him, our consciousness plays a big role in how we see the world. Space and time aren't real things, but more like how our animal brains understand stuff. Lanza also says biocentrism helps explain a lot of quantum paradoxes and puzzles. He even thinks that it might be a better way to bring all of physics together than Einstein's famous theory of relativity. So, let's take a look at 7 important ideas in biocentrism. The first one says that reality is connected to our consciousness, and what we see depends on us looking at it. We've got this idea that the universe exists on its own, even when we're not looking at it. If you have the kitchen in your house, the kitchen is always there, right? Well, not exactly. Our eyes capture tiny packets of light, but the real perception of colors, shapes, and movement happens in the back of our brains. Everything we see is because of light bouncing off objects and interacting with our brain. So, without our brains, the kitchen would be just a bunch of random particles. In other words, when you're not in the kitchen, there's no real kitchen there. It's just a bunch of possibilities, like a shimmering swarm of matter and energy. It's pretty challenging to think about, isn't it? But to truly understand the universe, we need to go beyond our habitual ways of thinking. We need to embrace a viewpoint that's simpler, yet more demanding than what we're used to. We need to look at the world in a whole new way. Next, the second and third ideas say that particles behave differently when we watch them. Sounds creepy, right? But it's actually true. We observe this phenomenon many times in many experiments in quantum mechanics. Yes, particles actually change their behavior if they know they're being observed. It gets even crazier. Some particles can even instantly influence each other, no matter how far apart they are. It's like little atoms have a secret connection that defies space and time. This is why Lanza believes that bringing the observer into the picture, like us humans with our thoughts and perceptions, can help us understand things better. He thinks that the observer is the missing puzzle piece that can help us find a way to bring all the laws of the universe together. The fourth idea says that consciousness is super important, and without it, things get all fuzzy. Like we said, everything is intertwined, and there's no separate universe out there that's not connected to living things. Biocentrism suggests that the external world, everything we see, actually depends on us, the biological creatures. We're not just passive observers with clear windows to the world. In fact, without us interacting with the world, it's like the universe isn't really there. Just like the kitchen disappears when we're not there, and the universe is all about how we experience it. Reality is a dance between us and the world. It's a whole new way of understanding everything. The fifth idea points out that the universe seems to be just right for life to exist. There are over 200 things in the universe that have to be just right for life and consciousness to exist. If the Big Bang had been even slightly stronger, everything would have zoomed by too quickly for galaxies and life to form. That means no us. And if the forces of nature, like gravity, and the strong nuclear force were tweaked even a little, atoms wouldn't hold together, stars wouldn't ignite, and we would be left with plain vanilla hydrogen everywhere. Of course, there's many theories on why this could be the case. We could also look at this phenomenon the other way. It's not that things were made this way specifically for us, but our existence is a result of things being this way. We're just the result of particle movements and certain conditions. Biocentrism, however, has a more fun way to look at it. Life creates the universe. The universe and its parameters are a reflection of the logic of our existence as living beings. And finally, the sixth and seventh ideas say that space and time are not things, but tools our animal brains use. Think about it for a moment. Does time really exist? Well, the reality of time is a bit shaky. According to biocentrism, time is simply our way of making sense of the world, a tool for understanding. It's not some external force. Our mind weaves together snapshots of information, creating the illusion of time. So when we perceive time passing, it's just our human perception at work. And what about space? In our daily lives, we think of space as a vast container without walls. But in reality, space is full, not empty. There's no fixed measure of distance anywhere. You believe that you're far away from your kitchen, but everything around us is just a bunch of atoms almost without any empty space in it. Well, There you have the basic ideas of biocentrism. In his books, Lanza explores these ideas very deeply and tries to answer philosophical questions, like if death is just an illusion, or if plants are aware of things. They even talk about whether machines can ever become conscious. Some people aren't sure if this theory can be proven right or wrong. Unfortunately, there's no way for us to test it right now, but Lanza hopes that in the future we can do cool experiments, like huge quantum superposition thingies, or either prove or disprove his theory. Until then, it's more like a cool idea than anything. No matter which theory you prefer, one thing is clear. We live in a truly peculiar world. So let's keep exploring it and discover new, amazing things. Might our universe not be real? What if everything around you, your home, your car, your city, is unreal? What if it's
just some kind of computer simulation?
You can relax now. Scientists are going to find out. First of all, what does real mean? One of the definitions is when an object, say your car, has some definite properties that don't depend on measurement or observation. It means that the universe exists external to our minds. For example, your car will have 4 wheels even when you're not looking at it. This is something we call local realism. But if we take into consideration quantum mechanics, everything gets a bit dicey. Apparently, several theoretical physicists might have proven that the local realism view on the universe is likely to be false. I mean, what? According to the scientists' findings, the universe can't be locally real because particles can't have definite properties prior to their measurement or observation. It means that the simple process of observing a particle can change its state, which, as you see, contradicts the principles of local realism. In short, the universe is only real when you're looking at it. The conducted experiments demonstrated that 2 particles, regardless of the distance between them, might still remain connected. This concept is known as non-locality, and according to it, 2 particles can travel as far as to different ends of the observable universe and still remain linked, behaving like a single unit. Interestingly, this idea contradicts Einstein's theory of relativity, and in theory, it makes the universe random. But it's still unclear why it happens and what we can do with it. Another idea connected to the unrealness of the universe is that it's just a simulation. But who or what could have created this simulation? There's 3 possibilities: that we're unlikely a simulation, that almost no technologically mature civilization would be interested in running a computer simulation of minds like we have, or that we're almost certainly a simulation. Some experts think that all 3 possibilities could be equally possible. But if the first 2 were false, then the third one would have to be true. Maybe our descendants from a very distant future would be able to run a super complex computer simulation. And then there could be millions of virtual universes with billions of simulated brains in them. However, doubts about the reality of the world around us aren't the only scary thing known to people. Let's talk about the theory of the Great Filter. If you get to think about it, the universe has to be filled with countless life forms. But people haven't stumbled across any of them so far. According to one of the theories, somewhere out there, there is a great filter. The main purpose of this filter is to stop and finish those civilizations that advance to the level of star colonization. If we suppose that this idea is true, there are 3 possible scenarios for our civilization. A. We're unique because we've passed the Great Filter. Other civilizations haven't managed to do this. B. We're among the first potential colonizers. Before, the conditions in space were too harsh for life forms to leave their home planets. In this case, chances are high that we'll soon encounter other space civilizations. C. We haven't reached the level of technological development that is advanced enough for the filter to locate us. This means that we haven't passed the filter yet. Consequently, the trial is still ahead of us. Then, there's the false vacuum theory. It claims that our universe exists in a false phase state, which means that it's just a temporary thing. What's more, it's only a part of a larger universe. If you compare this large universe with a kettle full of boiling water, the universe we live in will be just a tiny bubble on the surface of the water. But this can't keep going endlessly. One day, perhaps in billions of years, this false vacuum will burst. And then the visible universe around us will instantly vanish with a pop. There won't be any preliminary warning, and we'll have to somehow deal with it.